special guest, now Professor Dr. Chao, to come to share with us tonight. So we went to the same college in university. So very happy to see my classmate. And then he came to study for the advanced degree in the United States. So he got his PhD in the earth science. After he got his degree, so he went to work for NASA in Maryland for many years. And then he returned to Taiwan. Then he became a professor in the Central University. Actually, it's the chair. Then he moved over to the Institute of the Earth Science, the Academia Sinica, Taipei, Taiwan. So now he is an outstanding researcher for the Sinica. So he has retired, but even so, he still have some classes. He still teach students. So now we're going to start the talk tonight. So I actually like the topic very much. So it's a very important topic, very related to the human existence. So it's about the water circulation on Earth. So now we are experiencing so-called huge impact of the human activity on Earth. So hopefully we can understand more about the water circulation on Earth. So the Chinese expression about water is that the water can carry ferry, but also sink the ferry. So that is from the Emperor Taizong in the Tang Dynasty. Yeah, so he had a dialogue with his prime minister. So he mentioned that expression about the water can carry ferry, but also sink the ferry. So the topic is fairly broad. So hopefully I will be able to wrap up everything in 1 hour. I used to work for NASA for more than 20 years. So I used the photo from NASA. It's a very famous photo. It even has a nickname called Blue Marble. 1972, NASA, the Apollo 17, the last time to get on the Earth, the moon. So on the tree return from the moon to Earth, so they took this Photoshop, the color photo of the Earth. So since the 70s, all the environmental activities, they all like to use this photo as a symbol. So it's probably the most widely used and spread the photo of the Earth. You can see the Africa, the continent of the Africa. And you can see the cloud, the Antarctica, very thick cap, the ice cap. So the big portion is a blue ocean. So we could say that the Earth actually is a water world. So that probably there's a movie called Water World about 20 something years ago. So you talk about the global disaster, the whole Earth were flooded by the water. So that was a story of that movie. So from the space, when we look at the Earth, we can really see that it's a water world. So the circulation of the water on Earth is a big portion of the water is from the ocean, about 70% or more. So the water from the ocean will kind of produce the vapor to the atmosphere, right? And then the clouds will form, and then some will drop back to the ocean, some will drop, the raindrop to the land. So you can see the percentage or the quantity of the water on the slide. So the really big portion of the water is really in the ocean. So you can see the number. So the water circulation and then the quantity through the whole entire circulation. So it's a trillion ton, the unit is a trillion ton. So it's about 1,000 gigaton. So it's equal to the 1,000 cubic kilometer. So you can get a sense when you walk for 1 kilometer, how long it's going to take. And then 1,000 cubic kilometer, how long, how wide. So that's about 1 million trillion ton, the unit. So the quantity, the volume is huge. So the circle is at the ice. You see the ice, the quantity of ice is very little portion of the total water in the ocean. So the surface flow water is only 40, and that's an even smaller portion. So all these numbers you see on the slides, it's kind of like give you an idea, an overview. So the cubic kilometer. So the three the Sunshine, the Three Gorges dam in China is about 0.04. If we use the same unit, so 0.04 trillion ton. So that is the biggest dam in China right now. So you can see how that compared to the whole big picture in terms of the water circulation on Earth. So you see the river, right? The quantity of river, the soil moisture, the groundwater. So far, I just talk about the surface water. Then also including the groundwater. So about 97% of ocean coming from the ocean. Only about the 3% or less is the fresh water. And then about 2/3 is still kind of store the water in ice. So only 0.5% the groundwater, the soil water, the atmosphere's water vapor is only 0.0%. So the visible water means the river, the creek, the lake. So all these usable water, only fresh water is only 0.01%. So that's very little portion. All these are the surface water. Now the second topic about the mantle water. So it's under the ground. So those water coming from the ground, inside the ground. So this water kind of lock in to the crystal formation in the rock. So it's not really like an ocean under the ground. No, it's kind of formed in the crystal of all the rocks, all the formation inside the earth. Yeah, so the usable fresh water. So you can see this current slide. So you can see the green color. You can clearly see that's more moisture, contain more water. So you can clearly see the distribution. So this is the proportion based on the different nation, the different country. So you can see, the graphic on the right and the left. You can see the kind of related. So if you look at the China, the mainland China, the water clearly is not that sufficient. So people can get the idea. So the surface water, of course, the biggest portion will be the ocean. It actually determines the climate patterns of Earth. So the current, the ocean current, you see all those are current that really determine the weather pattern or the climate pattern. So the warm currents, the cool currents. So that is the flow of the current on Earth. Yeah, because the Earth turned and also turn around the orbit. So the water will kind of naturally just kind of flow based on this current. So the current flow just a couple 100 meters. It's not very deep, but it has a huge impact in terms of the weather or the climate. So this is kind of like a nature current pattern. So these slides probably more kind of mentioned more rarely. So the first one on the upper left-hand side is based on the sunlight. So, and then the water will flow based on that current. So the lower right-hand side is the photo from NASA. So the deep water current will be very different from the surface water current. So the deep water current, the kind of deep ocean, we still don't have a clear picture of it. So we kind of estimate. Yeah, so it's much kind of slower speed. When they make a whole turn, probably will even take 1,000 years. 1,000 years. So it's very deep and very slow. So the upper right, so you can see the surface ocean water current. So has some sort of like a vibration based on the surface temperature. So you can see El Nino, November 1997. You can see that as the pattern. So in the Pacific Ocean, the temperature changes based on the different pattern. So in the La Nina is a reverse pattern. That's in 1998. So the lower right is a kind of natural movement. So the next topic, probably the last maybe 20, 30 years, we talk about this topic more seriously about the climate change in terms of the human activity. But this slide is all about the natural condition. So the man-made human activity impact is still quite small. If we look at this slide. So the climate change is a global warming or the greenhouse effect. Yeah, I can quickly go over this concept. Probably everybody already very familiar with this topic. It's just like a greenhouse in your garden. It's pretty much the same concept. So you have a glasses greenhouse in your garden. So the sunlight can penetrate the glasses roof. So inside the greenhouse, you can clearly feel that the temperature will rise. So once when you circle with the whole glasses, so the light can penetrate. So the water will raise. So that's called the greenhouse effect. Right, the show wave is a blue color. The warm air rises heat, and that's the red color rays. So this is a similar analogy to the Earth, built on the surface of the Earth. So we have a kind of thin cover about the CO2 or the CH4, the H2O. So that thin cover, almost like the same function in terms of the glasses greenhouse. So you're going to kind of hold the temperature. Actually, these are pretty much the natural environment. However, if the man-made activities will alter such a condition, then the man-made impact will happen. So for example, man-made CO2 increases, So you can see the pattern since 1958 and to the 2020. We call this called the kneeling curve. So it's the increases of the CO2 based on the mimic condition, healing curve. So you can see the CO2 goes kind of up and down. So the key factor is that the CO2 is just keep going up. So about 4 decades ago, so the unit is a parts per million, so about 320, and just keep going up. Now it's more than 400 parts per million. So the other important factor is CH4. So it kind of exacerbate the situation, kind of speed up the whole process in terms of the warming, the global warming. So the lower right-hand corner, the glacier kind of shrinking. You can see that. So this is the most notable changes. So on top of all these mountains, right, the glaciers kind of retreated already. So all this information, you probably can just Google it. You can find it everywhere. So the Norway's Svalbard, 100 before, 100 years before, and 100 years after. So the glaciers 100 years ago, you can see it's kind of covered the whole land. But after 100 years, you pretty much don't see much glacier on the land. So where did it go? It melted and then flowed to the ocean. So the upper right, the Alps, the mountain. So the lower part actually it was covered with glacier, but now it's kind of shrinking, it retreated. So the lower right hand corner is the Tian Mountain in China. So from the 1850, it just kept retreated. So we already noticed that such situation many decades ago. So this is the permafrost. So this area is very big. The northern Canada and northern Russia area. So about 1 or 2 meters is all kind of frozen ice. Even so, they already kind of started to melt, and then the speed is kind of speed up. You can see the mama's elephant already kind of came out from the surface. So such a big area, the big scale of the area. So after it melts, where did it go? Right to the ocean. So it has a CH4. Originally, CH4 was frozen in the ice, but after it started to melt, then CH4 will come out. So this is a more scary factor in terms of the global warming or the effect of the global warming. So in terms of our understanding about the permafrost melting issue, our understanding is still very limited, but the impact is pretty scary. So if we talk about the Tibetan platform, like a southwest China, so that whole area is a permafrost land. So you can see that on many newspaper magazine. So it's Arctic. On the left is Arctic, the north of the Canada and the Greenland. Particularly the Greenland, you could see a big ice cap kind of cover the whole area. September 1984, usually the ice cap will be kind of the smallest in the September. So that's usually the situation. But if you look at the photo, also in September 2016, and then when you compare it's shrinking. Of course, in the winter time, the ice cap will grow. But this is the end of the summer. You can see how small it is now. So this is already the fact, already the reality. So the ice cap, melting of the ice cap, in terms of the raising the sea level, the impact will be a little bit lesser compared to the glacier because they share the same volume, because it's floating on the seawater. So on the left is the Arctic. The Greenland is the biggest island on Earth. So the ice is very, very thick, could be even 1 kilometer, 2 or even 3. So the other is Antarctica. So it's kind of sea ice. So the look at the parameters, all those are the ice forming from the sea. So if you compare the area, the size, so Antarctica is much bigger than the Greenland. So if we talk about the melting of the Greenland, it's going to be about 7 meters. The quantity of the sea level will rise about 7 meters if the whole entire Greenland will melt. So if the Antarctica, if that melt, it will be about 70 meters. So if you add it up, it will be maybe even closer to 100 meters. These are just the kind of estimated number, but you can see the huge impact. So the brown color you see on this graphic, so after the raise of the sea level, and then will be under the water. That's about the 100-meter raise of the sea level. So if we talk about the majority of the human habitat area, so that is really the huge impact in terms of human existence. So this is a graphic in terms of the raise of the sea level. So about 30 years ago, scientists started to measure, and we gradually see the raising of the sea level. So it's about a global measurement. So you can see the pattern. So each season, for example, the summer, the winter, it will be kind of going up and down about 1 centimeter. So you're going to see kind of going up and down, going up and down. That's a natural pattern. But if you see the trend of this pattern, this red line, that is not the natural pattern. Particularly the glacier melts and then flows to the ocean. So particularly, for example, during the summertime, right, the water will expand, so the sea level will come up. So that kind of seasonal changes is natural, but the overall average pattern can still be clearly seen. So you see the average trend is about 3.5 millimeter per year. So if you look at the last 3 decades, you can see the impact. So if you subtract the seasonal factor, the seasonal changes, but the average pattern is keep going up with a kind of exponential factor, it going kind of even faster for the last few years. So these are measured from the satellite, the measurement from starting from 1992. So they started the Poseidon, the satellite measure system in terms of the sea level. They use radar to measure the sea level. So after 1992, more satellites joined this global sea level measuring program. So if you look at this pattern, it's already very clear. This trend is very clear in terms of the global sea level rising up. So this is another topic, also the man-made effect. So in terms of the raising up of the sea level, because we build so many dams to hold the water to prevent them flow back to the ocean. The 3 gorges, right? In China, the biggest. So all these big water dams, they hold the water. So we actually block about 3 centimeters in terms of the sea level. So if we didn't build all these water dams, actually the rise of the sea level will probably even higher because we hold the water in the water dam. So this is the graphic of all the natural disaster. So we finally started to pay more attention in terms of the impact of the tsunami. This is the historical tsunamis. And you can see the impact, how many people were killed, and also the year. So this is the simulation. It is 2000 11, right, that was a tsunami occurred in Japan. So they use a computer simulation program try to measure the impact of the tsunami occurred in Japan. So the impact in terms of the area and also the speed. That speed goes pretty fast, almost like a passenger aircraft. So for 3 hours, you can see the impact of the tsunami. So in less than a day, it already reached to the other side of the Pacific Ocean. So it is almost kind of faster than riding on the passenger aircraft. So that's the speed, the impact of the tsunami. So the tsunami we saw actually is kind of at the seashore. But if that wave get kind of average in the center of the ocean, it kind of get average out. So for example, when the tsunami occur at the seashore, you can see it's very, very high. So when you get kind of gradually spreading to the middle of the ocean, you probably don't even feel it. Yeah, if you kind of get on the fishing boat, you probably didn't even know the tsunami just passed through the bottom of your boat. So this graphic, so the natural pattern or the natural changes in terms of the climate changes. Milankovitch's cycle. It's about 100 years ago. It's a mathematics. Mathematics research the angle between the sun and the earth, and then that caused by other planet. For example, the Venus, the Jupiter. So what kind of impact in terms of the relationship between the earth and the sun? But the time span actually lasts several 10,000 years. So in terms of the orbit, right, how the earth will move around the sun, he found the 3 cycles about 10,000 years. In the 1970s, so this cycle actually determined in terms of the ice age. For example, the last 1 million years, we probably have 10 cycles of the circle. So each cycle is about 100,000 years. So every 100,000 years will be the circle. So this is the last ice age. So we can see the melting of the ice cap, right? The Greenland, pretty much only Greenland is still there, but the surrounding is all melted. And also the Antarctica. So even just a few degrees of the temperature rising up, it would not melt a big amount of the ice. So for example, the whole entire Canada was covered by ice during the Ice Age. So these are the snowfall, right, from the seawater. The seawater, raising up, and then the snowfall on top of this mountain. So about 10,000 years ago, the sea level was about 120 meters lower than today's sea level. So that is the time when the Earth has the most amount or the quantity of the ice. So you can imagine, for example, if the sea level drop 100 meters lower, so you can see the expanding of the land, the continent. So we talk about the upper origin. So where did they come from, particularly the North America and the South America? So when and where did they travel from Asia to the North America and then the South America? So they pretty much just walk, because during the Ice Age, the whole area is just the land, the continent. So they could just walk across the continent from the east to the west, from Asia to North America. So during the Ice Age, they could migrate to this area from Asia. About 10,000 years ago, because the land was there, so they could just cross the ocean, by walking through the land. Human migration through the natural environment. So these are the perspective from the satellite, and see the water distribution. So this is a program called GRACE. So during the different time period, where would the water would go? So the water circulation keep changing. The red means that so you see the upper. In the past, no, it was the ice cap, but that melted. This is Alaska, the blue color. So it's getting lighter and lighter because due to the melting of the ice, so it became much lighter and lighter. The Greenland, particularly the southern part, the ice also melts. The Antarctica, so the ice melts, and then that is called the blue color. And then we have the drought in Australia. So you can see the water distribution in terms of the global perspective. So all I have been talking about are the surface water. So we pay attention to the surface water. So the visible water, the surface water, is about 0.01%, and even the percentage is so small, but it has the huge impact in terms of human activity or human existence. So the mantle water even is called kind of under the earth, but even so, it's still on the surface in terms of the earth, probably about maybe like 1 kilometer. So it's the water in the crystal formation in the rock. So we normally would think that actually the rock is usually dry, but not really. So some kind of crystal formation will also contain some water. But we don't have much understanding about the mantle water. So the Plaque movement on the surface of the Earth, we probably also know a little bit about that. So the Plaque is a very thin cover or on the surface of Earth, and then will be kind of constantly moving. Yeah, we probably know about that. There are two main categories. One is a continental drift. The other is a sea flow spreading. So the continental drift is about 100 years ago, this concept. So this sea flow spreading is about after the World War II. When you put these two concepts together, so they gradually kind of bring out the conclusion, okay, we have a much clear photo or concept about the Plaque movement. So the sea flow spreading, it kind of push the Plaque to two sides, and then it get pushed up, and you are also coming down. So it get pushed and go down. So the ocean volcano will come out and push the Plaque, and it keeps spreading, and then it will sink in. So that's also one of the main reasons there will be water content under the earth, the subduction. So this subduction movement will carry some water to the earth. So when the Plaque get pulled down, it's about a couple 100 kilometers. All this coming from the earthquake major data. So based on the measure of the earthquake, so why in that area, that portion, the speed of the earthquake kind of change kind of became a little bit slower. So we kind of assume or estimate maybe that area contain some water. It's about a couple 100 kilometers. So that blue area, we call it the mantle transition zone. So the whole area is all rock, all the cliffs of the earth. So the soil, the rock, the whole area. We use some computer simulation, try to kind of estimate the quantity of the water. That quantity could be not even comparable to the quantity of the water in the ocean. But just need to remember, it's not like the ocean under the earth. Those water content in the rocks, the soil. The more shallow area under the earth, probably a couple kilometers. So the earthquake, we know that it usually will happen between the Plaque. So the water under the earth will kind of replicate the earthquake. So this is the St. Andrew Fault. Probably is the most studied the fault in the world, the Pacific and the California. So the two plaques meet over there. There are also some kind of subset, like a smaller fault. The major fault is the Andreas. It's couple thousand kilometers, even extended to the ocean. So 1906, that was the year the big earthquake in San Francisco. 1857. So that was the earthquake there. After such a big earthquake, it has been quiet for almost a couple 100 years. So the next big one is kind of waiting for the next big earthquake. So this centerpiece so far hasn't been observed with a big earthquake, but there were a lot of smaller earthquakes. So you will accumulate the energy and then erupt in terms of big earthquake. So those smaller earthquake is up. The analogy is like you push the toothpaste. There will be a lot of like a smaller earthquake. Release the pressure, the energy. So we kind of estimate those are gray area with a lot of smaller earthquake, probably the water content more in this region. So that middle section, so we have so-called the subsurface water. Now, so we can get some basic idea about the water circulation or distribution on Earth, and particularly the so-called the man-made impact for the last 100 years. So it's good to have this kind of big picture understanding. So the water can carry the ferry, but also sink the ferry. So that will be the end of my presentation. Thank you for listening. So would you be able to answer some questions? So if you will have any questions, please either raise your hand or just type your question in the chat box. The mantle water, would that be possible? It would come out of the earth. Yeah, so the mantle water. So far, we don't have that type of the technology yet because it's very deep. Because it's not like the visible water. So that's kind of ready to use because it is inside the rocks. So basically couldn't be directly used. So basically such kind of water is just on the kind of understanding based on such theory. But in terms of the usage, we don't have that technology yet. So the underground water, right, about 0.5%, the soil water, underground water, right in the middle, the circle you can see right now. So that portion, the proportion is way higher than the visible water. So for example, the sinking of the land, particularly in the central California, because many agricultural or farming, any kind of activities suck out a lot of groundwater. So that result in the sinking of the land, actually many, many meters. If we human don't overuse the groundwater, it's really a good resources. So for example, the rainfall, the majority of the rainfall, people will try assume that you will go to the ocean. However, also will go back to the ground, go into the ground, become the groundwater. So this graphic, so right in the center, right, we have the most rainfall. So all the rain forest all there. When you go to the higher latitude, because it's much colder, So also not lacking of water. So pretty much the center area, we experience most lacking or insufficient of the water. So many deserts in those areas because no rainfall. So this is in terms of the weather pattern or the ocean current. So in the center of the America, and then the center of China, some area we still have water, but in Africa, we don't. So that's also the seasonal wind. The East Asia, the wind blows north and south. So based on the different temperature pattern or the proportion in terms of the continent versus the sea. So the wind naturally blow north and south. And then because the wind blow from the south to the north, so it carry the water, the moisture from the ocean to the land. So it's kind of like the gift not given from the heaven. If you don't have that kind of seasonal wind, then like the Africa area, so all desert. So in terms of the sea level rise, we see the pattern of it. However, the energy of the sea level hasn't been observed yet. But the tsunami is pushed by the energy from the earth, so it's a release of the energy. So if there is the earthquake in the sea mountain, so that will naturally cause the tsunami. So the source is the earthquake, because the earthquake the sea mountain released the power, the energy that pushed the water and became the tsunami. So the sea level rising up, the impact to the tsunami hasn't been clearly observed yet. But in terms of the glacier in terms of the Alaska area, we observe more impact. It's more like a smaller scale, the earthquake, the impact from the earthquake, and we observe in some area, particularly with the glacier in the Alaska area. So in terms of your CO2 model, will that be the chance to turn back, or we already passed the threshold in terms of no coming back? So this is about 20 years. We try to reduce the CO2, reduce the carbon footprint, but still climbing up. If we didn't even try to reduce the CO2, reduce the carbon footprint, so it's still going up. So it's kind of exponential factor, it's going even faster. So it's not we stop all the human activity, you will stop. So for example, if we don't produce more CO2, it actually will still go up. It will still go up. And then after a certain amount of the time period, it probably will get flattened a little bit and coming down. So this is only about two-thirds from the human activity. You can see the pattern, the two-thirds of the impact, because the majority of the CO2 has been observed in the seawater. So the seawater actually absorbed the CO2. And then the rest, that's about two-thirds. So only one-third coming to the air. So this is the impact of only one-third. So if you look at that from that perspective, so the impact is even more severe. So it's a pretty scary situation we are facing right now. So even if we stop producing CO2, then the seawater will still release CO2 because it's a global impact. The region is huge. So it's pretty much no turning back. No matter you do or you don't do, you will still go up. So the question is about the global warming, the impact in terms of our human life. So for example, if you live in the very low, the area, the island, particular island area, very close to the seashore, so you probably will already see the impact due to the rise of the sea level. So it really depends on where you live, where you are located. So you probably can sense that the winter is getting warmer. And then the weather storm is getting harder and harder. The El Nino pattern is more often, more frequent, and then carry more energy, more power. So you probably could directly feel the impact. And then this is just the beginning. So for example, if the sea level keep rising up and then really go into the human habitat, the intensive area, so that would be really a big impact. So for example, there could be some good impact. For example, the high latitude area, it was covered with ice. Now, if the temperature becomes much warmer, so no vegetation, more trees to grow over there. So the natural environment will also adapt to the change of the global warming. So we have been creating such a situation, kind of we trap ourselves. Yeah, it's all human. It's all man-made. Okay, so Professor, you have a class, so you probably need to catch up to your class. So if we have more questions, we probably will just collect it and email you. So we really appreciate Dr. Chao share his story. Since you're going to have a class very soon, so you have to run, then I can continue to share the future events. Okay, thank you all. Really appreciate your listening. So the next week, yeah, is also the alumni from the National Taiwan University from the physics department. So Dr. Chen. So the topic is about the universe in terms of the time and space. So he obtained his PhD in physics UCLA in 1984. And then he became a researcher in Stanford University from 2000 to 2007, about 7 years. And then he returned to Taiwan. After that, he got the honor of the French award. So right now he is a distinguished professor in National Taiwan University. Also the professor of the cosmology and particle astrophysics. So we kind of very looking forward to his talk next Sunday about the cosmology and the Earth.阿弥陀佛，法师听得到吗？
你可以带我们回向吗？你听不到吗 ？OK， 那就请你随时都可以开始。呀，你要的。你回到 Chinese room 来吧，就是我们一般的 room，可以吗？如果不行的话，那我就带。那我就带了 ，OK。我们用中文。愿